Okay, so this is the video for 7-3, day 1. There's no new vocab, but we do have is a review of the steps that we're going to use. This is just, multi-step equations. Really just two-step again today. And so what we're really looking at here is these are kind of straightforward. Your first step is still, make sure you write it down correctly, right? And these really mostly won't include distribution. They aren't going to include combined like terms. They're just those nice two steps we've been doing. So you move on to the add and subtract phase after that, and then the multiply and divide phase. One of the big differences you'll notice here is we're going to use that reciprocal idea again. And just a reminder of what that means is if I have 2/3, right, x, and I multiply that by 3/2, that's how we get that canceling out to get x by itself thing going on. So these are going to look a whole lot like those nice two steps we're doing, only I'm going to include fractions and decimals. Don't freak out. You just have a couple extra steps in there when you're using, decimals, things like that. You got to remember those other extra operations. So, anyway, so next slide is going to start out with an example. Our first example is 2/3 n minus 6 equals 22. And again, as we said, following our steps, write it down correctly. Well, I don't even have to do that because I kind of cheated and screenshotted out of the book. Next is the add and subtract phase. So I'm going to add that 6 to both sides. So remember, whatever number is not attached to the variable gets added or subtracted. I don't care if it's a decimal, a fraction, what it is. I'm going to draw that line down the middle that you guys all know I like. So 2/3 n equals 28. Now we're down to that reciprocal idea, and whatever's attached to the variable, you have to multiply or divide away. If it's a reciprocal like this, right, if it's a fraction, use the reciprocal. That's what I'm trying to spit out. And that means on both sides, right? Same number, 3/2. So over here, it lets me cancel out the 3 and cancel out the 2 to get that n all by itself, right? And when it comes to the fraction, there's lots of ways. You can multiply it and then reduce. I'm going to start out by pre-reducing. Remember, you can cross-cancel. 28 and 2, the 2 becomes a 1. 28 becomes a 14. And 14 times 3 is 42. And if you don't believe me, you can check it out. That's where it might take you a little extra step there, right? Multiplying that 14 times 3, because I kind of know that one. So, and again, if you want to do the check, you shove that 42 back in here and multiply it through to prove that it's true. So there is your n equals 42 on this one. The next slide includes two examples for you, the next two slides rather, two examples. So what you're going to do is you'll pause after this one and go into Class Kick, and you'll work two examples, and then double click, come back to the video and watch your answers, and then you'll move on to another example, so on and so forth. Look for that big pause there. So here's what we said is the pause. Go back to Class Kick, work the practice problems. I think there's 2 of them. When you're done, come back here and check your answers. You'll do that a few times in this video. That way, just make one video for you. So we're back. You should have worked this in Class Kick already. And we're going to show our work here. And again, copy it down correctly. And again, I cheated. Add and subtract. So subtract the 14. Subtract the 14. Here's where you have to try to remember that you're going to have some integer operation fun going on here. So over here, we're going to have negative 7/10 k equals, and we're going to get negative 21 minus 14. That doesn't become 7 or minus 7 or negative 7 or something like that, right? We're technically adding 2 negatives, and we're going to get 35 out of the deal. Then we're going to go back and use our reciprocal. So you can do negative 10/7 or negative 7 over, or negative 10 over negative 7. That's what I'm trying to spit out on both sides over here. Negative 10/7. And again, these all cross-cancel, right? The negatives even cancel out. So I get k equals. Now, luckily here I came across some more cross-canceling. These pluses, the negatives cross-cancel, become positive. And 35 and 7, 7 becomes a 1. 35 becomes a 5. 5 times 10 is 50. That's our answer on that one. Now your second example here that you're supposed to have worked, again, draw on that magic line. Add that 4 to both sides. Add that 4. 2/3 m equals 7. And here we're going to use that reciprocal again. Multiply both sides by 3/2. So again, flipping over that fraction. Becomes 7/1 times 3/2. And here all that cross-canceling fun happens, and m equals 21 halves. And if you like mixed numbers, some of you do, it's 10.5. But either answer is acceptable because it is a reduced fraction, even if it is improper with 21 halves. So the next slide is another example I'm going to do, and then you'll pause again, and so on and so forth. So you guys get the idea. Here I've added another little fraction to it, right, making things a little more fun. And your answers here can be fractions. I know that kind of freaks out some of you, but it's okay. I promise. So draw on that line that I like. And again, subtract 2, subtract 2. So I've got 2/5 x equals. So here I have 3/4 minus 2. Obviously, it's a smaller number minus a bigger number, so the answer is it's going to get negative there. We now are going to take, again, we're looking for the difference, and that's actually 1 1/4, or 5/4, so it's negative 5/4 in this case. And we're going to go back, and we are going to multiply by the reciprocal to clean this up a little bit. So on both sides, I'm going to multiply by 5 halves. Multiply by 5 halves. And just when you thought it was going to get nicer, it's not. So we're going to, and don't forget the negative there, right? So these guys all cross cancel. X is going to be negative because negative times positive is negative. And 5 times 5 is 25. 4 times 2 is 8. So negative 25/8. Some folks like the mixed number version, negative 3 1/8. I think you've got only one example after this one here. Again, the important part is keep track of all that stuff you do with the fractions. Don't freak out and go, oh my God, I don't know what to do. Just keep track of it. Keep working at it. You're not, under time constraints here. I mean, that kind of thing. So here again, pause. Go back to class kick and work the practice problem. I think there's only one for this part. And then come back here and check your answer. All right, so checking your answer on this one. Now, some folks want to go subtract y from both sides. No, not appropriate. What we're going to do instead is you're going to look in front here and you're going to add 7/12 to both sides. Add 7/12 to both sides. So that means y is going to be whatever this is. It's obviously going to be a positive answer. So I have 1/6 plus 7/12. You need a common denominator, don't forget that. And this becomes 2/12 and 7/12, which is 9/12, right? So y is, now look at this. I don't even have another step. There's nothing even attached to the y there, but this fraction does get reduced. So it does reduce to 3/4. And if you don't remember how to do that, divide out that 3 there from both and see that works out for you. There we go. 3/4. Or you throw it in the cake, whatever method you like the best. 3/4 anyway for y on this one. So another example from me, throwing in the decimal fun right here, right? I know you love it. I know you love the decimals. Okay, I'm lying. I know some of you really hate them, but just get over it, right? So looking up here, we need to obviously subtract the 20, right? You're not going to subtract 0.15x. That doesn't make any sense. So subtract the 20 from both sides. So I'm going to get 0.15x equals, now lucky for me here, right, I've got 37.25 minus 20, and so it's going to be a positive answer because it's a bigger number minus a smaller number. Here's the trick though, right? So 37.25 minus 20.00. Don't forget those on there, right? So 5 minus 0 is 5, 2 minus 0 is 2. Bring down your decimal. 7 minus 0 is 7. 3 minus 2 is 1. Right? So we're going to have 17.25. So 0.5x equals 17.25. Now the fun part, right? We are going to divide both sides by 0.15. Oops, that's a 1, I promise. Divide both sides by 0.15. So remember, that's really 17.25 divided by 0.15. And when you do that, you can't have decimals on the outside of the division, so bump it over twice, bump it over twice. So it's really like 15 going into 1,725. And, whatever method you want to use, right? Let's go with, it goes into 17 once, 15, it's a 5, I promise. There's a 2, bring down a 2, goes into 22 one time, right? 15, I got to borrow here, don't I? 7, and bring down the 5, and 15 goes into 75 exactly 5 times. So 75, and I'm done there. So my answer, there we go, x equals 115 exactly. Okay, so again, show your work, take your time. No sense on rushing this. Do a good job. Oh, and show all work. Okay, so I do believe we've got a couple more to take a look at here for you. So as we said, pause here. Not a couple more, this is only one more. Pause here, and I got one for you to work, which, by the way, comes out nice. Alrighty, so we're going to start out by, make sure you copy down right? In their add and subtract phase, add 3.6, add 3.6 both sides. This extra little decimal point means nothing there. That's a 3. Stuff's tough to write on sometimes. 1.5x equals, okay, so I've got 2.4 and plus 3.6, right? Bring down your decimal. 6 and 4 is 10, carry the 1. 6, right? We get 6 there. So 6.0. Now we have to divide off that 1.5. And I like to show my division as a fraction. I don't care how you show it. X equals, so I've got 6.0 divided by 1.5. Bump the decimal. 15 is 60. Oh, that's exactly 4 times. There you go. So X is 4 on the one you're supposed to work yourself. Now your homework today is all decimal fun. Tomorrow I'll give you a few more fractions, but I think you need some practice with decimals. It's reteaching 7-3.